Welcome to qnawire.
Hi, so in this question, what we actually need to do is to employ the uncertainty principle that tells us that the uncertainty on x times the uncertainty on momentum is going to be larger or equal than h bar over 2. Remember that h bar is equal to h over 2 pi. So we can express the same relationship as h over 4 pi. Both of them are correct. Okay? So first of all, we know that the uncertainty of velocity is equal to 10 meters per second. So, in order to know the uncertainty of momentum, remember that momentum is mass times velocity. If the mass is going to be constant, as is the case here, the uncertainty of momentum is nothing but the mass times the uncertainty of velocity. So, delta x times delta p will be equal to uncertainty on x times mass times uncertainty on velocity. And this needs to be larger or equal than h bar divided by 2. So we want to know the lower limit for this uncertainty. So we are going to keep the equal value directly. So the lower bound that we're going to get tells us that delta x times mass times delta v is going to be equal to h bar divided by 2. Thus, the uncertainty on position will be h bar divided by 2 divided by 1 over mass times uncertainty of velocity. So, substituting the values over here, for h bar we know that this is equal to 1.0546 times 10 to the minus 34 joules per second. Well, joule second, sorry. Joule second. This is going to be divided by 2, 1 over the mass. In this case, the mass that we're dealing with is the mass of nitrogen. So nitrogen corresponds to having 28 atomic mass units. That, if you do the conversion from atomic mass units into kilograms, you're going to realize that this is equal to 4.65 times 10 to the minus 26. Okay, so here we have 4.65 times 10 to the minus 26 kilograms. Remember that we're going to keep everything in the International System of Units just to have the result directly in meters. And the uncertainty of velocity, we said that was 10 meters per second. So, after doing this operation, the uncertainty on x is 1.134 times 10 to the minus 10 meters. And this would be the minimum uncertainty that we can get on delta x.